Welcome to this lesson on comparing with fractions and decimals. Today we're going to talk about how to compare fractions with the same numerator, compare like fractions, and compare unlike fractions with different numerators, and compare unlike fractions by relating them to 1/2, and comparing fractions and decimals. Alright, so there's three ways that we can look at comparing with unlike fractions. We can look at, do they have the same numerators? When they have the same numerators, the denominator doesn't matter, but it can help us determine which one is larger. So we're going to take a look at how to use that. We're also going to relate them to 1/2. So we know that 1/2 means 1 out of 2, or half of the shape. So what does that mean for something that is like 3/5? Is 3/5 more or less than half? And how can we use that to help us compare? And then, as always, we can make them into like fractions. All right, so first we're going to look at unlike fractions with the same numerator. So here we have 5/8 and 5/10. They have the same numerator. So what we're going to do is we're going to draw it out and take a look at what's happening here. So here I have 5/8. So I took my rectangle, and now I have to make them the same sizes. And I'm going to color in 5/8. Now I have 5/10. So notice I took the rectangle, and it's the same size rectangle overall, but what happened to my pieces? My pieces got just ever so slightly smaller. So when you cut something into more pieces, those pieces have to get smaller. Think of a pizza. The more slices you have on a pizza, the smaller the pizza gets. So let's look at 5/10. 1, 2, 3, 4, 5. In this case, we know that 5/10 is smaller by looking at the picture. Well, what if we just ignore the picture? We know we have the same number of pieces, so we have 5 and 5, but since 8 is the smaller denominator, we know its pieces are larger. Okay, so that's a little bit backwards for us, but 8's the smaller denominator, so its pieces are larger than the rectangle that's broken into 10. So 5 out of 8 is going to be more than 5 out of 10 because the pieces are bigger. So when you're comparing unlike fractions that have the same numerator, you can use the denominators. The smaller denominator is going to be the larger fraction. Okay, so let's try a couple. So in this case, 12, the numerators are the same. 12 is the smaller denominator, so that means its pieces are going to be bigger. Think of a pizza. If you split it into 12, you have a certain size, but then if you have to split it into 16, those slices get smaller and you get less. So somebody who gets 7/12 is going to have more than somebody who gets 7/16. Here, 1/5 and 1/3. Again, we can go through and we can draw it out. You just have to make sure that your original shapes are the same size. Okay, so mine is a little bit off, so I am going to fix that. Okay, and I split this into thirds, so 1, 2, 3, and 1, 2, 3, 4, 5, 1/3, 1/5. Again, the more pieces you have, the smaller they get. So 1/3 is going to be greater than 1/5. Here we have 21, we have the same numerator. 100 is smaller than 1,000, so 21/100 is greater than 21,000. Okay, so plain and short, when the numerators are the same, so in unlike fractions that have the same numerator, compare the denominators. The smaller, actually we'll say the fraction with the smaller denominator will have larger pieces So it will be the larger fraction. Okay, but again, it has to have the same numerator. You can't just do that if it doesn't have the same numerator. Okay. I'm actually going to underline same so you remember. Okay, so now comparing using 1/2. So let's look at 4/5 and 2/3. The denominator tells us how many we need in each group. So I need 5 and I need 3. Well, if I have 4 out of 5, do I have more or less than half? So more or less than half. So we have to think, what's half of 5? Well, I know I divide it by 2, and it's going to give me something with a decimal. So to have half of 5, I have to have 2 1/2. Then 2/3. Is it more or less than half? Okay, so I need 3. To have half of a group, I would have to have 1 1/2. Both of these have more. So these would be fractions that are an example of fractions that will not work when we compare using half. Now, the other part of this is when you have fractions that will work like that. So 5/7, is it more or less than half? And 2/6, is it more or less than half? So 5/7, we have 7 divided by 2 is 3 1/2. And then 6 divided by 2 means we have to have 3. So here we have less than half, and here we have more than half because we have 5 and we need 3 1/2. Here we have 2, but we need 3. So since 5/7 is more than half and 2/6 is less than half, 5/7 would be the larger fraction. All right, now we're going to make unlike fractions into like fractions. So this is where we go through and we find the LCD by using the LCM, or we could use the GCF. We get into all of our fun acronyms. So we have 4/5 and 2/3. So I'm going to put 5 and 3 into my ladder. They can only be divided by 1. So then I take and multiply my L numbers. 5 times 3 equals 15. So I'm going to turn 4/5 and 2/3 into fractions with a denominator of 15, so they become like fractions. Okay, so here, I know that what I do to one, I have to do to the other, so I'm going to take that 5 and I'm going to multiply it by 3, but what I do to the bottom, I have to do to the top. So I get 12/15, and here I'm multiplying by 5 and by 5, so I get 10/15. So now I'm comparing and I have the same denominator, so my pieces are the same size and I need the same number of pieces. So now I can determine which one is larger. Well, if the pieces are the same size and this group has 12 and this group has 10, then the group with 12 obviously is larger. So 12/15 is greater than 10/15. Okay, so we'll try a couple more here just so we can get that practice of finding the LCD. So we have 12 and 16 as our denominators. Both are divisible by 4. And I get 3 and 4 divisible by 1. So I take out 3 and 4 and I make my L. And I'm going to ignore the 1 because anything times 1 is itself. So I have 4 times 3 is 12. And 12 times 4 is 48. So my LCD is 48. So I have 7/12 and I have 5/16 times something gives me 48 times something gives me 48. I know 12 times 4 is what gives me 48. 7 times 4 gives me 28. And I know 16, well, 16 times 2 gives me 32. 16 times 3, maybe that'll work, because 16 times 3 gives me 18, so that gives me the 8. Carry the 1 gives me 48. So even if you weren't sure if that worked, you can always go back and test and make sure that you get the right number. So that way you multiply it by the right number on top and on bottom. So here I have 28 48ths, and I'm comparing it to 15 48ths. Again, they're the same size, so I know that 28 is going to be larger than the 15. We'll move that down here, and then I will change my pen color. So I have 9 and 16. Oops. Try that again. Make that purple. Now I will change my pen color. So I have 9 and 6, not 9 and 16, 9 and 6. 9 and 6 are both divisible by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. Divide by 1. I have 3 and 2. So here I make my L. I get 3 times 3 times 2. I get 9 times 2. That is definitely looking like a 12, so I'll rewrite that. And I get 18. So my LCD is 18. So now I have 5/9 and 5/6, and I have to multiply them by something to get to 18. I know 6 gets multiplied by 3. I know 5 gets multiplied by 3, and I get 15/18, and 2 and 2, so I get 10/18. Now I compare 10/18 to 15/18. 15 is more. My pieces are the same size because the denominator is the same. 15 is more, so 15 is the larger fraction. All right, so now when we take this on to comparing with fractions and decimals, you have to do one of two things. You either have to turn the decimal into a fraction or turn the fraction into a decimal. When you're making your choice, look at the denominator. In this case, 12 is not a power of 10, so it doesn't make sense to change 35/100ths to a fraction because it's going to be 35 out of 100, and then you're going to have to make like fractions. So don't make more work for yourself. If the denominator is 10, 100, 4, 2, 25, 20, those types of numbers, then absolutely convert it to a decimal. But in this case, we want to convert it to a fraction to make it easier. So I know I do 12 and 7, so it's 7 divided by 12. 12 goes into 7 0 times. I subtract and I get 7. Bring down the 0, bring up the decimal. 12 goes into 70. Well, 12 times 4 is 48, and 12 times 5 is 60, so it would be 5. And I get 10. Add the 0, bring it down. 12 goes into 100. Well, 12 times 7 is 84, so 12 times 8 is 96, so we can try that. 8 times 2, just to double check, is 6. Carry the 1 and we get 9. Subtract and we get 4. Add the 0, bring it down. 12 goes into 40 3 times. Minus 36 because 12 times 3 is 36. I was jumping ahead to the fact that I get 4. And I add a 0 and bring it down. And I get 40, so I know this 3 is going to repeat. So my new problem becomes 0 and 583 thousandths repeating. And I know that 5 is the first number after the decimal, and it's bigger than 3, so I know 7/12 is bigger than 35/100. Here I have 3/8. Again, this can't easily convert to 10 or 100, so we're going to divide. I have 8 on the outside and 3 on the inside. 8 goes into 3 0 times. Subtract, and I get 3. Add your decimal, add the decimal up on top. And now I can add a 0 and bring it down. So 8 goes into 30 3 times. 3 times 8 is 24, and I subtract. When I subtract, I get 6. Bring down the 0. 8 goes into 60 7 times. 8 times 7 is 56. I subtract and I get 4. Add the 0. Bring it down. 8 goes into 40 5 times. Subtract the 40 and I get 0. So 3/8 is equal to 3 and 75/100. 4 and 3 are in the same place value. They're both in the tenths, and since 4 is bigger than 3, 4/10 is bigger than 375 thousandths. Remember, it doesn't matter how long the decimal is, it all depends on the place value. So here you have 4/10 as opposed to if you were to ignore, so let's ignore, put a little circle over this. If you were to ignore this, well, maybe we can't ignore it. So we're just going to pretend that it's not there. Then you know 3/10 would be smaller than 4/10. Don't worry about these numbers afterwards because they're just making the pieces essentially smaller. All right? Because remember, when you add zeros on after this, it doesn't change that value at all. It just changes what it looks like as a fraction. Again, ninths, not easily changed, so we're going to divide. 9 goes on the inside. 9 goes on the outside. 5 goes on the inside because it's 5 divided by 9. See? You can make mistakes when you try to go too fast. Okay, so I know I'm going to have to add that decimal and that 0, so I might as well just add it in right away. Bring down my 0. 9 goes into 50 5 times. Minus 45 gives me 5. Well, I'm noticing something right off the bat. It's going to give me 50 again. 9 times 5 is going to be 45. So this is a repeating decimal, and it's that 5 that's repeating. So here I have 0 and 5/10 repeating, so these two things are actually equal. All right, so you have a bunch of problems for you to try on your own. You have some comparing with just using the numerators with unlike denominators. And then you also have using half as the benchmark. And you also have fractions to turn into like fractions and fractions and decimals. So please make sure that you're using all the different ways that I've given you, because sometimes when you can use it and compare to half, it goes a lot faster than if you were to have to make like fractions. Right. As always, if you have any questions, please be sure to ask or email, or please be sure to write them down or email me so we can go over them in class.